Hello everyone, welcome to your final problem set. In this chapter we learned about machine learning. We didn't do lots of coding. I tried to kind of give you a crash course on concepts around machine learning. We spent a little time on something called random forest models and decision trees. And then a little bit talking about what deep learning kind of actually is and how you should be thinking about approaching it if you want to learn more about it later. The next thing you're going to learn, and this is as part of your problem set, is about support vector machines, a type of supervised learning model. I'm actually going to get you to build a support vector machine. That's what you're going to do. It's not as complicated as you think it is. There are tons of extra guides out there, and I'll go through step at a time what I want you to do. So I know it might sound a little intimidating, but I made my instructions for this task a lot clearer, I hope. Or at least not a lot clearer, but a lot more direct in terms of like the tasks I want you to do. So step by step. So you don't have as much as free options available in order to the decisions that you have to make. It's more specific. So hopefully that'll make it a little bit easier for you guys as well. So in this task, you're going to train a support vector machine, guys. Use the iris dataset though. So we're going to use the iris dataset to train our support vector machine. I'm telling you to create an X object, which has all 4 flower, petal, and leaf dimensions, widths and lengths. And then also to create a Y object, which is the target, the label for that flower's dimensions, as a number between 0 and 0. It's either 0, 1, or 2, which correspond to actual classes of flowers in another part of the iris dataset dictionary object. Then I want you guys to subset your data into training and testing sets, meaning I want you to block out a piece of this iris data set so that you can run some sort of so that you can make sure that you can test it later on. We're going to train on all of this information, but we don't want to give it everything because it might do something called overfitting. We want to separate a little bit so that we can then, once it's been trained, see if it guesses the target, the flower class type correctly. You can subset it in any way, guys. I'm not going to tell you how you should do your subsetting. You can use something called k-fold cross-validation. If you want to look that up for how we do that, the standard way of doing that. But because this is an intro course, I'm not too concerned about getting you to do that kind of method. It's a little bit more advanced. So subset your data in any way. Take at least 10% of your data out for test data though. And that I want both the flower dimensions as well as the target for that dimension as separate objects, test objects. You can call them test Y and X, for instance. Then we're going to train the support vector machine. We're going to use something called a linear kernel. I'll show you what that function looks like in the next slide. But basically, we're saying how we want it to do its classification, how we want it to try different ways of splitting the data. And then once it's been trained, you want to pass in new information, like new petal dimensions and flower dimensions, and see what it guesses. And if it guesses right, it's higher in accuracy. If it guesses wrong, we can do some sort of accuracy measurement, like we count how many times it guessed right as opposed to wrong, and that can be our accuracy measurement for this support vector machine. That's what I want you to do for evaluating this SVM. You can think of other ways of evaluating it, more sophisticated ways, and if you do, extra points. But a simple one for now is all I'm kind of expecting of you guys, so you understand the concept behind it and the parts that go into it. So what do you need to know for this problem? You need to use scikit-learn, but you need to call the scikit-learn package and build the model. And that's basically what's doing here. We're building the model parameters and getting it ready to be trained. And so we're support vector computation or support vector machine. And then we tell a kernel equals linear, and I'm saving this model to an object called model. And then because this is a scikit-learn object, there's a couple of functions that go into it. When we're training our data, when we want to use our training data, or training our model, we use .fit. And then we're going to use .score at some point to give it some Y data as well, and also do a couple of other things. I'll show you what that looks like. You should also look into what .score does. And then we're going to pass in our test data and predict to see what it guessed, what it guesses. And if it guesses right, we're going to count it. And if it guesses wrong, we're going to count that as well and give that evaluation. So I used enumerate, guys, in this problem set. Enumerate is almost it's used I use it in a for loop, because what it does is it gives you a list with the index position as it gives you a list with or a tuple with tuples in it, and each individual tuple gives you the index number as well as the data that's in it, because I wanted to use that index information specifically. So look at what enumerate does. It's not too complicated. You've handled this stuff before, and you might actually have a way of doing this without enumerate. So it's kind of like depends on how you build your code. You're gonna have to deal with some list manipulation, because you have to load this data set and extract some information and build training and testing sets. You need to do some logic operations, because we're going to be comparing predicted scores to actual scores. So we need to count that stuff some way. And then we need to evaluate the model accuracy by giving some sort of accuracy score. And you can do that in many ways, guys. I'm just going to give you a simple one, okay? And there are more sophisticated ways if you want to do this like for real, for like big companies and stuff. But in the end, this is the process of what's going on. Okay, with that, let us move into, I'll try at it, and then I'll see you in the answer section.